Hey everyone, who all is here? If you're in the chat, feel free to say hi right now. We're gonna get started. My hair's looking all crazy today. I don't know what's going on. If you're in the chat, feel free to say hi. Brian's just his wacky self. No more coffee. No more coffee though. Got some lunch, so I'm having a good, relaxing afternoon. Seeing what's going on right here. Awesome. Gonna respond to a few people here. If you're in the chat, let us know. Let's see. We've got ads on Discord. So many things. So many things. Mutual service ad. Aw, Chill Cat. It's chill. This is called. Good to see you here, Fleming. What are you working on, Fleming? Let us know. We can do some chapter 13, some decision trees. We did decision trees earlier. My hair's just getting so long. Terry Higgins actually has longer hair than me. I found out today. I was like, what's going on with the world? Terry's got longer hair than Brian Stevens. It's crazy. Crazy world we're living in. So, but I'll take it. I'll just grow my hair back out longer. But if you have questions, let us know. Let me see. Yep. So, did you cover the... We can do canvas content. Yeah, let's do that. Awesome. Helping people out on Discord. Let's do some canvas content, Fleming. Great advice. That would be awesome. Getting the canvas content loaded up right now. Fleming, here's some points. I appreciate it. Let's take a look at that canvas content. We'll do a version of the canvas content. People can search around and find all the canvas contents. So let's take a look. For some reason, it never saves my changes. Let me make sure they're saved in both classes. Get both canvas contents changed and looking good. Sometimes there's a question that, like, it asks for a specific way to do the question, and then it's like, why don't we just put in both ways? So I correct things. Well, let's take a look here at some canvas content. Here we go. Canvas content. Okay, we're going to take a note right here. We're at the 3 minutes and 20-second mark. Canvas content number 6. Do a version of it. We can do another one if people want, but it's your call. It's your office hours. Let's hang out and do some work. So when doing decision trees, categorical variables with more than 20 levels, so going to the extreme right there, should what? And so it's talking about kind of the creation of a tree. Now, anytime you use an X in a decision tree, it will increase the R squared. So that's just theoretically wrong. When X's are included in a tree, and let's take a look at this. Let's look. We got some trees open. If we start including more X's in this tree, we were doing a tree earlier. Including an X means adding it to the tree. So if I make another X in the tree, I put another X in here. And Fleming already knows, great work right there, Fleming. They should not be used. So adding X's increases R squared. So that's theoretically wrong. They definitely should not be used. Are treated like continuous? No. They just are not used. They have too many levels. They actually cause problems with the tree, the way the tree works. So we don't use them. When doing decision trees, the split history shows us the what? So the split history shows us the what? Ooh, this is a good question, because if you know what the split history is, the answer might not look clearly on the screen right here. So here is the split history down here on the bottom. And what is the split history showing us? And I've got two different paths right here. The split history shows us after each split, and I did two different types of trees, so we got two different values over here. The split history shows us the value of what after each split, and we can go again, split, and you can see right there. We can go again, split, and it's showing us the value of what after each split. I think I have the notes open for it. I'm going to go to my favorite set of notes on this. I guess this one. The split history shows us the value of what after each split. So what does the split history show us after each split? And this is a perfect example. I've already got the answer on it, though. Go back to no answer. The split history is going to show us the value of R squared after each split. R squared is how much of the variation in Y we are explaining. And generally, R squared, well, not generally, it will go up as we make more splits, but at some point, it might sort of level off. So we might see this point at here that it's kind of flat from here going forward. And at this point, we might say, well, really, doing additional splits isn't really helping the tree. And what do I mean by splits again? Well, splits are every time we click the split button, we add an additional X and we keep splitting, splitting, splitting. And we're trying to explain if people have broken a bone and we're asking about the Confederate flag, apparently. So I don't think we should be splitting it that much. And so when we think about the answers we have available to us, has nothing to do with the slope. There's no slope in a decision tree. Slope is not a thing we talk about. Visually display the tree. Well, it's displaying the R squared. It's not displaying the tree. There's not a p-value that we use. That there's ways I could talk about with Gini coefficient and stuff, but not for us. There is no y-intercept. These are concepts for regression. Decision trees do not have slopes and intercepts. So those answers should be eliminated immediately, saying no, slope and intercept is a regression topic. P-value is not what's displayed right there. So we're really down to visualize the display of the tree, and the visual display of the tree is found right here. That's the visual display of the tree. But here we're seeing the R squared after each split, and as we saw in the example, it's going to determine how many splits to use. My favorite note for this is this slide, because as you can clearly see, we don't see an increase in R squared really after 3 splits. So the split history is showing us the history of R squared and telling us, should we split it more? Should we stop here? That is the split history. And the concept of a population is key to inferential statistics. Now, a lot of people have missed this one because they say, wait a minute, Brian, you taught us SSPP, sample statistics, population parameters. But what does the infer part mean? So Fleming or anyone, 100 points. If we're inferring things from statistics, statistics let us infer things about the what? Or our sample. Lets us infer things about a what. The point to collect a sample is to infer things about a what, which kind of makes it a key concept. So like if I say I'm going to get statistics to make inferences, that's why we call it inferential statistics. Yeah, Fleming, you got it. Yeah, this is very true. It is true that samples give us statistics and populations have truths, which are parameters. Like the parameter for in-state for UT might be 60% in-state. So that'd be the truth. Like if that's true, that means 60% of UT is in-state. But we might go out and talk to 200 students and we might get an estimate of 50%. So from 200, we'd get a sample statistic, which is an estimate of the truth, which would allow us to infer or make guesses about a population of interest. Like what percent of all UT is in-state? We could get a sample, get a statistic, and make inferences. So the key word right here is that the inference part is that statistics allow us to make inferences about population parameters. Very, very important right there. A researcher wants to examine the grams of fat in milk. They separate the milk into whole milk, 2%, and low fat, then randomly select cartons. This is an example of what sampling. Now, take a vote in the chat. No one will know who answered what. We've got here, let's put all the answers. Cluster, simple random sample. Let's see, do we have a bunch of people watching? I hope we got a few. Systematic. And last but not least, stratified. Okay, so take a moment. Vote in the chat right there. And so I'm preparing for my presentation. So when we have cluster sampling, items are divided into clusters randomly. We then do a census on the clusters. Probably the best way to summarize what we do. We can go into more detail, but this is what we have. And looks like chat knows what's up. Good answers, chat. And then we have stratified sampling. We acknowledge a difference and then sample randomly within those differences. We select the clusters randomly too. Systematic, every kth. You'll usually get that one right. And simple random sample. Everything is a number. And then we randomly... Everything has an equal and likely chance of being selected. We randomly select. So you have to... One of the keywords right here is census for the cluster. That's really what you want to look for with your cluster sampling. Stratified is correct. Because we're stratifying on what? How would you explain to me how we're stratifying this? Like you could say the difference we are acknowledging is what, Fleming? So Fleming, you're very correct. It might only be one vote, but still I'm very happy. Fleming, another 100 points. The difference we are acknowledging right here is what? Like what difference? There was one vote. 100% Fleming. The difference we are acknowledging here is what? Like you'd say, oh, we're stratifying it on what of what? Like you could say, oh, we're creating different groups that we're going to draw from samples within each group, because that's what stratified is. It's not taking all of one group, that's clustering. You would say we're stratifying these samples on what? I swear there's a 50-50 guess on the test when people choose between stratified and cluster. And I'm like, no! When I see that people miss it. We are stratifying on type of milk. Type of milk. Like, what kind of milk is it? Does that make sense? Like, so this is where the stratification occurs right here. Because, and it doesn't say we select all low-fat milk or all whole milk or all 2% milk. We are taking within the strata being the groups, and we're taking randomly within the groups, random cartons. Now a carton is just a sample of one. It's not a cluster. If you took like a one of those things that the milkman carries around, I don't know what they're called, but if you grabbed one of those and had like 4 milk cartons in it, then that would be a cluster. But the carton itself is the sample. So each carton is one sample, and then we're taking random cartons, so the carton is the sample. Maybe people think the carton is the cluster, but we're not taking all cartons from low fat. So you would need to take all of a certain group. This is the stratification right here. Definitely stratified. Last but not least, we have the bus questions. This is going to take a moment. Okay. What do we got here? Okay. Still doing that. Suppose that the probability a bus arrives on time is this. For the next 3 stops, what's the probability that the bus is on time for at least one of those stops? And this is where we need to start drawing it out. So here we are. We need to write down our notation. The probability the bus is on time is equal to 59%. The probability the bus is late is equal to thus 41. It's either on time or late. It can't be something in between. And then we need to think about what we're trying to find. We are trying to find the probability the bus is on time for at least one stop. At least once on time. Now, at least once on time is something that could occur. As in, maybe it was on time for the first stop, the second stop. Let's draw that out here. So we could have instances of the 3 stops, and it's on time for the first, the second, and the third. Hey, it was on time at least once. It was on time for all 3. Or there could be other scenarios where it's not on time for something like the second. Well, then it was on time for at least 1. As long as I color in one of these yellow, it's on time for at least 1. As in this scenario, it's on time for at least once. But there is a scenario where it's not on time for at least once, and that's when it's late, and we're just kind of doing the probability of late right here as this color. So this is where it's late for all the stops. It was not on time for any of the stops. So either the bus is on time at least once or late for all. Now, when you think about these as 2 separate groups right here, on time at least once or late for all, one of these things must occur. It's either the case that the bus was on time for at least one stop, or it's late for all the stops. And now we're on to something. Now we could take this right here, and knowing by the rule of addition that since these are disjoint, they can't both happen at the same time. The bus is either on time at least once or late for all the stops. We could have added together these events. Now we get to algebra, and with algebra, we take right here and subtract. So we're going to take right here and subtract late for all from the other side. And the reason we're doing this is because the probability of late for all is a little bit easier to find. The probability of the bus being late once is simply equal to 0.41. And now we have the probability of it being on time. But this is the probability it's on time for one stop. What we would say right here is the bus was late for the first stop, the second stop, and the third stop. And the key word right here is and. So when you multiply things together, you're saying that these are independent events, as the problem states. So we need to know to multiply, we need to pass the rule of independence. And the problem, luckily, just tells us that. It's a key assumption. But assuming independence, we can multiply together these probabilities to say what's the probability it's late for the first, and late for the second, and late for the third. And remember, if you're doing a star, that means and. If you're doing a plus, that means or, and is the addition rule, which requires things to be disjoint. Make sure to write that down. Addition rule requires things to be disjoint, and the word is or. Where multiplication requires things to be independent, and the word is and. So now let's go ahead and multiply this out right here and solve for the answer. So here, I'll write it so we can see it. And we're going to just take this down a little bit here and reduce it or summarize it a little bit better. 0.41 raised to the third power. 23. There we go. And bring this here. And copy just so we can see all the steps. There it is right there. And last but not least, that will equal to this right here. We'll do it again. And just track your mathematics. Make sure you do it correctly. And that is the probability it is, what is it? At least once on time. I want to make sure I didn't misspeak at the end right there. Fleming, if you have more questions, let me know. This was the tougher problem. We did it. We followed through all the steps just to make sure we did it properly. We should get that 100. Report to 3 decimal places. Looks to be good right there. Submit the quiz. I think I've done it 4 times. Tell me I got another 100. Yee, good. 10 out of 10. Oh, maybe I didn't do this fast. You're welcome, Fleming. Good work right there. We'll see if there's more questions. But good work. Just hanging out right now. Drop by if you got questions. Let me know. What questions do you have? Drop them in the chat right now. Let me see right here. Discord. Pokemon Go. Oh, we gotta look at this loop stuff. I wish I can I mark a chat? No. I wish I could. I shouldn't have clicked it. People are saying, "You're welcome, Fleming." I said thank you earlier. So you're responding to a few Discord messages. Wait, questions earlier. Oh, need to respond to that. Let's see. Let's see. Oh, no questions. We're chilling out. Let me put up the Ask Taking Questions stream. We'll see. Just taking questions. It's a relaxing stream today. Next week, I bet it's going to be pretty crazy. Next week is going to be, whoo, with the test. Next week, it'll be day before test. And test day is going to be crazy. Chilling out. Mubot see any future texts? Which chapters is over in recommendation? Oh yeah, let's talk about the test 1 recommendation. Test 2 recommendations. Oh my gosh. Fleming, great questions. I'm watching the chat still. Looking over the presentation I'll be giving. Presentation. 21. Stat 201. Test 2 advice. How's your week going, Fleming? I can't believe it. It's like semester just starts up. It goes so quick. It goes so quick. Every semester I'm like, starts, it's over, summer happens, winter happens, new year. And I'm just like, oh my gosh. It's almost like we're just getting closer to being back in Knoxville, which is good. Can't wait to be back. But I'm just like, man, time has flown. It's crazy. 21. Apparently I blinked and like barely any seconds passed. I think I took the wrong timestamp. Let's go check out the test. Here we go. Okay, it's time for some amazing rolls. I know, right? It is crazy. I love that emoji right there. So the test 2, and you'll see it right here, we'll do review 2. And Mubot should know review 2. Mubot knows it all. And review material for exam 2 right here. So let's hop into it. He's pointing us to the page right there. And we've got all the practice sheets up. Spring 2022, awesome. Chapter review videos, videos for test, and speed runs. Love it. They're all here, ready to go. And I think we don't have stuff we shouldn't have. We'll check. Got sampling distributions, all that great stuff. Simulations, all those good things. Simulations, just talking about some randomness right there. And there it is. I don't think confidence intervals. I need to talk to Terry because I'm pretty sure confidence intervals is not on this. I probably just need to remove the confidence intervals portion. Let me double check. Let's go look at the syllabus here. Terry has a thing where it says a silly bus. So cracks me up every time. 2 seconds. They recently changed the order of the book, and it drives me crazy. It's like we'll do something similar for like 3 years, and then they'll be like, oh, we're going to move a chapter. And I'm like, oh my gosh, stop moving chapters. Okay. Because I thought, there's test 2, here's material, and test 2, here it is. Sampling, I thought it was. Okay, good. So I need to change the videos a little bit. Hopefully no one's watching the confidence interval videos. It's on the sampling distributions. So sampling distributions are part of test 2. If you can't see right there, that's sampling distributions on test 2. Sampling distribution for the sample mean and sampling distribution for the sample proportion, which is technically, it's listed right there, chapter 13/14. It used to be that, and I think it was chapter 15 back then, that it was sampling distributions. So sampling distributions was its own chapter, and then confidence intervals were their own chapters. But now they say, let's group the proportion stuff together. Let's group the mean stuff together because there's a sampling distribution for the sample mean, a sampling distribution for the sample proportion. There's confidence intervals for the mean. There's confidence intervals for the proportion. So they just decided with a later version of the book, well, we're going to do it different. And so then we've kept it this way right here. So it's a little bit confusing. Sorry for like 13/14. I will say this, when we come back, I think we have like 6 or 7 classes when we were trying. I think we have 7. And this is not a lot, but they're more intensive of chapters. They are learning how to do hypothesis testing. So the last portion of the course is kind of pretty in-depth statistics. So make sure to come to class. Make sure to be working on the assignments. Anytime you're stuck on something, swing by office hours here and ask questions. But this is what is on the test right here. Linear regression, going back to interpreting stuff like the slope and the intercept, solving models. Regression wisdom, luckily these chapters are basically overlap right here. So those are really good kind of overlapping chapters in your knowledge. Decision trees, we just covered that yesterday for our class, and we did the earlier office hours where we covered interpretation. So great review. Check out earlier office hours. Sample surveys, this deals with bias and sampling methods. Also the idea of a sample frame, population, parameters, all the key terminology. Good chapter on terminology. From randomness to probability deals with like the multiplication rule, the addition rule, all those things right there. And one of the really good resources that we have, we'll go back to it, is Mubot here telling us about this chapter 2. And I'm going to make sure the videos are what the videos should be. Because, it's not going to hurt you to watch other videos, but you want to focus your time on what matters. Here's the chapter review videos, and it has right here, sampling distributions, good. Sampling methods, randomness. Probably need to move the randomness off here, huh? Okay, can I do that right now? Let me see if I can take it off here. I'm on my channel. Oh, I think I can remove it. randomness, and remove from chapter 2 videos. Yeah, get a little work done here while we're working away. So the video is removed, so we don't have to worry about that. And so now we'll reload the page right here, and no one will see that video on the playlist anymore. There you go, chapter 7, chapter 8, decision trees. These videos right here are excellent because they're basically focused reviews. Oh my gosh, double-clicking the button. If you want to go to decision trees, you can watch me work through some decision trees, talk about the output, and explain what's going on. Same sort of output, same things we know, and I list the leaves down here and do a little drawing over them so you can see which number leaf we're talking about, and interpreting the R-squared. Blank percent of the variation in Y is explained by the variables in the tree. Classic. And going through the notes on what you need to know and how to interpret it, especially when you look at the leaves down here on the bottom, 1, 2, 3, 4, and then you think about these and how they're associated, 1, 2, 3, 4 right here. So it's very important to know how these are associated. Once again, these videos right here are kind of a good cliff notes of what you need to know. There's some residual plots. You can see by it saying residual over there, and we're analyzing the model. These are practice test questions. So the practice test questions are really going to help you out going through and just reviewing test questions. Like, let's look at one right here. Suppose, let's do it right here. So Fleming, let's take a shot at this one. You ready? Suppose we consider a person drives to work on one day. Let event C, probability of event C, represent that the person is rear-ended by another vehicle before they get to work. Let's suppose event D is the person's getting to work without having any sort of collision. This was a question a lot of people got wrong. It says, find the probability of C and D. What would you need to know about these two? As soon as you see C and D right here, what do you need to know about them? If you see find the probability of C and D, you should think, oh, it wants me to what these events? I need to check what. So this is the practice we need to do. I'd say C and D. We were covering this earlier with Canvas content. I'd say this looks like I need to use the what rule, and I need to check this about it. So what do we have right here? So this is good practice. Always pause these videos and say, okay, how would I handle this problem? Well, I see it says and. Brian was going on about if you see and, it means a certain thing. So C and D. That's probability of event C and event D happening at the same time. Like C happens and D happens. So if we see the word and, we're doing the multiplication rule. So because we're invoking the multiplication rule, we have to ask, are the two things independent? Remember, when it comes to the multiplication rule, we're testing to see two things happening at the same time. This happens and this happens. If we're going to multiply their probabilities, they need to meet the rule of independence. And so we ask ourselves, are these independent? Well, we have event C is they get rear-ended going to work on the same day. And then on that same day, they get to work event D without getting in an accident. So if somebody got rear-ended, would you know anything about them getting to work without an accident? And the answer is yes. You would know they didn't get to work without getting in an accident. So the problem we get right here is that these two are not independent. And once again, independence means if you know one thing, would it change the probability of another? Like, let's say it's snowing tonight. And I say, well, do you think it's below freezing? You're like, yeah, it's snowing. I'm like, well, how do you know that? And you're like, because the probability of it being below freezing is it has to be at least in the atmosphere if it's snowing. For it to snow, it's a requirement. So you would know the probability, not like on any random day has a probability of being 10% below freezing in January in Knoxville. Because it's snowing, because event snow, you know event freezing. It has changed the probability. So we're in the same scenario here where if we know you got rear-ended, we know you didn't get to work without getting in an accident. And funny enough, it actually turns this probability into zero. It can't happen. You can't get to work getting into an accident and get to work not getting in an accident. And that might be the best way to consider these. And I know it's not total complements because there might be other things like you get into it says are rear-ended by another vehicle. Maybe the other percent of the time is you cause an accident. So there's other things that could occur other than to not get in an accident and to get in an accident where you get rear-ended. We should have maybe just put you get into an accident, you don't get into an accident. That made much more sense and they would add to 100%. But the problem here is a lot of people are going to multiply these probabilities because they're seeing the and right there. But if we're adding them, we would check to see if they're disjoint, which we could do. You could say, what's the probability of this or this? Awesome. No worries. Fleming, great work right there. And so we could add these because they are disjoint. You can't have them both happen, but we can't multiply them because they are not independent. And because of that, the probability is zero. I know it sounds crazy, but We can only multiply, and I go through the notes right here. So if you read this right here, I go through every little bit of notes. So I'd type down these things. So didn't I show a picture of an accident? I thought I showed a little, no, I thought I put a cartoon accident picture, but the probability would be 0. I guess I just say it. This is a trick question. So the answer is 0. And so when you're studying for the test, I would go here to the review page, and I would start it this weekend especially. Speedrun reviews are great. Do I have confidence for the mean and sampling distribution? Oh, that's sampling distribution. So that's why I included it. Confidence intervals for true proportion. I think this has the sampling distribution. Yeah, p times q over n square root. So it's got parts of it, hence why it's in here. The other one shouldn't have been here, but this has portions of it that we've been looking for. And long hair Brian there for you. So yeah, definitely good stuff. Margin of errors. And I think I included in the video description, like test 2. Oh, I say exam 2 right there. Yeah, so I've put it in the video description on when to do it. But really good review. And I would start this weekend. So if you're watching this right now, you'd want to go through here and start refreshing some of your knowledge to make sure you understand it, to be like, let me review this. It's very hard to learn things if you've only heard it one time. So you want to hear it different ways. You want to go through the chapter reviews, put them on in the background, listen to them while you're making dinner or something. You're like, I'm making dinner, I'm putting on a chapter review. You'd be like, I'm going to sleep tonight, I'm putting on a chapter review. I don't know if that would help, but the making of dinner might help. Then you might hear me saying, if two things are independent, we can multiply them together. You're like, if two things are independent, we can multiply them together. Like, what's it mean for it to be independent? I'm like, if they're independent, that means the probability of one happening will not be influenced by the probability of something else happening. And then you need to come up with your own examples for how that works, because I can just say that. We can write definitions down, but actually understanding it and communicating is the goal. So good work right there. We'll head back, but that's my advice for the test is start this weekend. I'll probably be mentioning that during class because there's assignments, there's lots of stuff going on. Start studying this weekend, put some time aside. We'll have another Kahoot. We'll go back here to the main screen. Let's do it. If you're in the chat, we're taking questions. Got time for more questions. Might head off here and answer some more emails. Let's see. See, people are saying, if you're here, ask questions. We'll see. It's such a quiet day. Set to 1 questions. Might take a break, might relax. We can do that. Would it be bad if we relaxed? Looks like people are having a relaxing day. Do we have assignments? We've done the 201 work. I think 475 has their assignments so far out. 320 is not till the weekend. We might take a break here, everybody. Take a little break. It's been a busy week. Office hours are chill right now. So we'll probably take a break. I'm replying to some emails and stuff in the background. Well, with that, if you're here, feel free to say hi. If you have a question, let me know. I'll be back. Teaching some 320. I'm going to see if there's a question. I'm gonna hit the button and then someone's gonna appear. Until next time, I'll see everyone in a bit. 320. Bye for now. Bye. That's not the right button. We'll be back. Swing by, everybody.